Hi, welcome back to Leetcode. So in this video, I'm going to discuss the second problem from today's weekly contest 483. The problem number is 3799 and the problem name is odd squares 2. So the problem statement is that you are given a string array words, okay, consisting of distinct 4-letter strings, okay, each containing lowercase English letters. That means small a to small z. And there will be only four character, right? 4-letter string. A word square consists of 4 distinct words: top, left, right, and bottom, arranged as follows. So that means there will be four strings, correct? One will be top, one will be left, another will be right, another will be bottom. So what is the condition? How should we arrange these four strings? The first is top forms the top row, okay. Bottom forms the bottom row, left forms the left column, top to bottom, and right forms the right column. So what the condition is that it must satisfy top 0, it should be equal to left 0. So the character present in this top word, the first character of the top word, it will be actually same as the word present as the left column of the first character of the left column, right? And similarly, it will be same as the character present at the index 3 of the top word. It will be same as the character present at the index 0 of right column, means the right word. And similarly, the condition bottom 0 equals to left 3. That means the bottom 0 means the bottom word. The character present at the index 0 is equal to same as the character present at the index 3 of the left word. And it will be equals to, and another condition is the bottom 3 equals to right 3. Bottom 3 means the index present at the index 3 of bottom word. It will be same as index 3, the character present at the index 3 of right word. Okay, so we have to return all very distinct word squares sorted in ascending lexicographical order by 4 tuple. So order will be first I have to return the top word, then left word, then right word, then bottom word. So let's take an example, then it will be easy to understand, correct? So we'll actually have, like, there will be multiple words, something word 1, word 2, word 3, word 4, word 5. Okay, multiple actually what can actually present. So now actually I will take suppose 4 word from this input string, these input words. So suppose the word 1, then word 3, then word 4, then word 5. Okay, so now actually I will assuming that this is actually the top, this is actually the left, this is right, and this is actually bottom. Okay, so what will happen? They mention that each word will actually have 4 character, mean 4 letter. Suppose it actually have, suppose let's take the real life example. So here actually we have 4 string, mean 4 words, correct? So this actually I'm assuming these 4 actually are the one will be the top, another will be the left, another right, another bottom. So avel, area. Suppose this actually avel, this is area, echo, and next is also, correct? So this is the 4 words I have trying to compare. This actually valid condition or not. So this is word 1, that is actually top. Okay, this is actually area, that is actually left. Okay, and echo is the right word, right column, and this is actually also this is the bottom word. Okay, so how should I have to arrange this? So I have to arrange this. First I will write top. Okay, that means I will write avel. Then here actually I have to write left. Left is area. Okay, next I have to write bottom. What is this? What actually I have chosen here? Actually also. So this will be also. Now I have to write the right word. Right word is echo. ECHO. Okay. Now what they mention that the character present is here. This is same as this. Okay. Okay. Now whatever the character present is in this index 3, that will be same as this in character present in the index 0. and whatever the character present is in this left word in this index, that will be same as this, the index 0 of the bottom word. Similarly for this, whatever the character present here, that will be same as this. Now this is actually top word, so that means if I want to compare these two conditions, that will be top 0 equals to left 0. Correct? Just visualize the actually diagram, then it will be more easy to write the code, because here actually the constant is actually very small, then actually we can actually easily solve by brute force approach. Okay, so that's why I'm just explaining the condition by using diagram. Okay, now this index, it will be same as this index, character present in this index same as this. So what is the index for the left word? It is actually 0, 1, 2, 3. So index 3. So left 3, it is same equals to the bottom 0. Correct? Next is this 2. So this is actually top index of 3. So top of 3, it will be equals to what? The right of 0. Correct? Next is this 2 character. These 2. That means right of index 3, it is same as the bottom of index 3. Right? Then actually we can say that this is actually square word. Correct? Now we have to actually check how many actually, like we have to actually check all the possible combination. Like first I will check word 1, word 2, then word 3, then word 4. Okay, then actually check that this actually word square or not. Okay, if it is possible, then actually I will store reason in our answer. Then actually suppose I will check word 1, word 2, then word 4, then word 3. If it actually all the condition is satisfied, then actually I will actually mark this as a valid word square. Okay, in this way I have to check all the possibilities or all the possible combination. Okay, that will be better. So we have to check, I have to explore all of this combination, then I will actually return this combination like in the sorted order. So this is clear. You can actually see that what they mentioned here actually in this condition here in this 2 line, that actually I have explained through this diagram. Okay, top 0 equals to left 0. Actually you can say top 0 equals to left 0, then top 3 is equals to right 0. Top 3 equals to right 0. Okay, just try to actually diagram draw the actually try to place all the words in this square, in this square way, then it will be easy to understand. Okay, so that is clear. Now actually how actually we can solve this problem, right? So I actually have multiple words. So now actually they mentioned that I have to explore all the possibility, all the possible combination. Now here actually you can see that how many actually what actually can present in the input array length. It actually maximum is 15. 15 actually what are possible. So we can actually use the brute force approach here. How? So here actually I have to check only 4 words, right? By using 4 words, because this actually square, I have to actually try to actually visualize the actually square, right? Square word. So that's why to actually make a square, I need 4 strings or 4 words. So that's why I actually need W1, W2, W3 and W4. Now it can between 0 to or like 1 to 15. Any word between 1 to 15. This word 2 can be 1 to 15. This word 3 can be 1 to 15. Alright, this word 4 can be 1 to 15. Right, so that's why you can see that if I actually explore all the combination, like 15 into 15 into 15 into 15, still it actually, let's calculate what is the time of study. So 15 into 15 into 15 to 15. So it is actually 5 into 10 to the power 4, 5 roughly. 10 to the power 4. Alright, so if we actually assume 6 into 10 to the power 4, 6000. So it is actually, sorry, 10 to the power 5. Okay, so it is actually 60,000. So it is still actually less than 10 to the power 8. Right, it is less than 10 to the power 8. So it actually work, right? It will work. So that's why I will explore all the possible combinations. So that means for top, I will try to select any index between 1 to 15, any word between 1 to 15. Then actually I will actually fix the left word between 1 to 15. Then inside that I will actually fix the right word 1 to 15. I'm explaining the brute force approach. You can also try to visualize that. Then actually I will actually fix the bottom word, any word between 1 to 15. Okay. So to actually generate all the possible combination, I can actually use a loop, for loop. Like for top word, I can actually use from 1 to 15. Inside that, actually for left word, I can actually use 1 to 15. So you can see that for each for each top W1, I will actually explore W2, then W3, then W4. Then actually I will still actually I fix all of this. Then actually what actually I'll do, next combination will be word 1, word 2, word 3, then actually word 5. Okay. Next actually I will fix still this three. I will actually fix this 3 word. Then actually change this word 6. Then actually word 7 in this way. Got it? So next actually I will change this to word 3 to word 4. Okay. Then actually again I will start from here again. That I will actually have word 1, word 2, then word 4, then actually word 3, start from again. Then actually again fix this 3 and it is changed to word 4, then word 5. In this I continue. Got it? The brute force approach. So in this actually it will take actually big of n to the 4, because there will be 4 nested yes, 4 nested for loop, right? So what it, now they've added extra one condition that I have to return the answer in ascending lexicographical order. Okay, that means I have to somehow sorted this. So what actually we can do, you can actually sort the input string. So anyways our top will be smallest, then left will be the next smallest, then right will be the next smallest, then bottom will be the next smallest. Correct? So if actually sort the input string in ascending order, then anyway our combination will be always in lexicographical order. Correct? Because I am first I actually change the bottom, then after checking all the combination by changing bottom, then actually I will change the right, then actually again I start from the bottom 0 or word 0 or something kind of word 1 again. Then actually I'll try to change the left word, then again I'll start from right word 1 in this way. So it will be anyways actually sorted. One approach you can do that at the beginning you can actually sort the input words. Okay, but here actually I have used actually set, like whatever actually the valid actually combination I got, that will store in the set, because set will be anyway stored in the sorted order. Correct? So that's why I have used that. You can also use that concept also, that to sort the input string at the beginning also. Got it? Now go to the code. So here actually you can see that the return type is vector of string, vector of vector string, because I have written all the combination, because it may possible there are multiple combination, and in each combination there are only 4 words. So I have written that also. So that's a vector of vector. This vector of string is the 4 words, and this vector is to store the multiple. We can actually have multiple actually valid square word. Got it? So that's why this is vector of vector. Okay, this is the ultimate answer we have to return. And here actually I have used set. I already explained why actually I have used set, and you can also sort the word string also, valid vector also. Okay, so here actually I have stored all actually the combination. Got it? Or each word square set of visited. So int n is the total word size. So I have to now check all the possible combination. Okay, so this is the first for loop is to fix the top. Okay, next for loop here I have fixed the left. Okay, next for loop I will fix the right, means the right word, and next actually I will fix the bottom word. Okay, now what I will do, I fix all of this. You can see that for each starting I have actually used starting from 0 to n minus 1. For left also I am starting from 0 to n minus 1. From right also from 0 to n minus 1. For bottom also 0 to n minus 1. Okay. Now they mention that all the actually distinct word, all valids should have distinct word square. So there is like we do not actually count the same word multiple times. So that's I'll check that if any one of this index is same, that means I have actually counted the same word at least twice. So that's why I have to validate, actually check this condition also, that this is distinct word or not. All four words should be distinct. So that condition is that all the four index I actually fixed, top, left, right, and bottom. All of those actually should be different, distinct index, right? And they mention that all the words actually I have actually it is actually they mention that actually all are distinct already. So that is fixed, that if actually pointing a different index, we actually have different word. Okay, so that's why I have to just check that we are actually pointing a different index or not for distinct index. So that's why I'll check that if is I is equal to j, or I is equal to a, or I is equal to b, or j is equal to a, j is equal to b, or a is equal to b, then I will continue. Next combination, try to explore the next combination. Now, if it is actually valid, that means all the four indexes are different. And now let's check that, like we have already validated that all the four word actually is distinct. Now to check that this is actually valid square word or not. So what is the condition to a valid square word? The condition is that top 0. This is the top word is word I, words of I, and that index 0 character should be same equals to words j, means the left word of 0. Okay, try to visualize this. Top 0 equals to left 0. This is the condition. Try to, it should be same equals to a equals to a. So that's why top of 0 equals to left of 0. Got it? Left word is this word j. Okay. Next condition is that left of 3 equals to bottom of 0. Left of 3, this a should be equals to this bottom of 0. So left of 0, left of 3 means this word of I, b of bottom. Yes, I is the top, left is the j. Yes, I of 3. You just actually follow this sequence, that will be better. For word of I, top right. This actually top 0 equals to left 0. Correct? And this condition is top 3 equals to what's a is the right. All right, a is the right, so right of 0. Correct? In here actually this e and e, available e and the echo e, this should be equal. Right 3, top 3 equals to right 0. Next condition is word b, bottom 0. Here they mention word of j. J is the left of 3. This is the bottom 0. Bottom 0 is the this a, means this condition. Bottom 0 equals to left 3. Clear? Next condition is bottom 3, it should be equal to what? Right of 3. Just check what a is the right. A is actually indicating, pointing to the right. What it, so this for condition is actually I am check all should be valid. If all of these actually condition is same, like valid, then I will say that okay, this is a valid combination. So I'll store in the set, not I am not storing into the answer now. So first I'll store into the set because I have to return as a sorted order. So that's the first store into the set. What shall I store? First I have to store the top, then left, then right, then bottom. Clear? In this order I have written, so that's I'll store in this order also, same order. Now after checking all the possible combination, I have to return the answer, this answer vector or vector string. So that's why I have to check that I'll iterate the set means this all the valid combination. So I'll store into the answer, because this set actually what actually I will get in the sorted order, because I'm iterating on the set. Okay, and then directly store into the answer and ultimately return the answer. Got it? So if there is no valid square words, so that time here our answer will be empty, because initially I have actually empty word vector. answer is empty. Got it? So I hope this actually clear. This actually just brute force approach. You have to just visualize and just write up the condition that correctly, that actually check the condition, correct? So if you found this video useful, and if you not yet subscribe, please subscribe channel. Thank you, and please like the video. Bye bye.